You'd be surprised by how much guesswork is involved in manual assembly. When operators are figuring out their own torque specs for screws, or what orientation or wiring direction to put critical electrical components in, there's potentially a cost to those bad decisions, which usually leads to expensive rework, scrap, and engineering time to diagnose those issues. In today's episode, we're going to walk through a few of the most common problems and how integrating smart tools can solve those to achieve consistent product quality. What's the cost of bad torque? Because we have over 24 screws in that frame, there's issues leading to potential challenges that we might find on the manufacturing floor. Because we could be breaking plastic parts leading to an inventory shortage or leading to rework time, we're going to have some issues because that can cause line downs for both material and labor efficiency problems. So we're going to walk through what it looks like to capture that information while we're using a smart torque tool and make sure we're capturing that quality properly. So when we have our frame here, there's a couple different items that we're going to be torquing as we go here. So instead of using tools like this Allen wrench here to do all of our manual torquing, we can set in some examples on how to do this properly using our connected tools. So when I arrive at this step in the instructions, it's going to be setting the program of my torque directly and automatically. What I mean by that is instead of having to worry about, am I on program 1, 2, or 3 with this tool here, what I can do is set that all via open protocol. So all of our torque tool connections are listed as part of our device library. This is specifically a Culver inline tool. We manage this connection directly via communicating to the controllers. And once I've gotten this in position, my normal, what I would expect to be doing today is using my Allen wrench to tighten these things up. So if I'm over torquing, I might be cracking some plastic parts that are connecting these frames together. When I get to that point and it does crack, these are small components. Individually, they might be, only a handful of cents each. But if I'm constantly cracking these and I'm just throwing them away and not notifying my supervisor, I might run into a production shortage because I'm missing all of these parts. Instead of using an Allen wrench like this, I can use my torque tool to measure these bolts. So when I have my assembly here and I start my torquing process, I have a fully torqued bolt here to 0.75 Newton meters, an angle of 152 degrees, and these count as I go. So as I'm torquing these and building, it's going to be showing me on the screen that I have 2 completed bolts, and it's going to show me my next pattern as I start going. So as I continue building and continue torquing here, it'll track all of my results for me. If I try to go to the next step in the instructions, it's going to stop me because I haven't completed all 16 of the bolts in this sequence. So we're setting the torque correctly, we're managing the quantity, and we are making sure that we're not going to the next step in the instructions until I've successfully captured all of my bolts. What's the cost of bad wiring once it gets into your assembly? If the pin diagram isn't correct, or we're putting things in the wrong sequence from a positive to neutral perspective, we might short out some of our components. Specifically, those circuit boards are a really high lead time item that might shut down the production line and are a very expensive scrap item. So how can we error-proof our assemblies to make sure that we're using our circuit boards correctly, efficiently, but most importantly, testing them before they continue down the production line? So what we have here is a setup of our controller for our machine assembly. We have the ability to plug in our motor. This drives the Z-axis up and down the assembly. When we plug this thing in, there's a couple different ways to manage this. We have a board that's very complex here. There's a high number of pinout diagrams. These are likely a high revision item as well because of constant software and firmware updates. These boards change quite frequently. So as an operator, if I haven't built this for a while and myself haven't looked at this board for a number of days now, this is potentially a new revision since the last time I built. So when we look at this board, where is the ideal location for this pinout? We have our work instructions. That's always our backup option when we talk about where these things go. When I plug this thing in, there's a couple different ways to verify this. I want to make sure I'm in my Z-axis 1 pin location, which is correct here. But now that I've plugged this in, have I put it in the right orientation? There's a color sequence here ranging from blue to black. Is this the right orientation, or is it potentially flipped in the reverse order? Of course, I want to have my pin diagram that's going to be telling me the right answer here. But a way for me to check this before I put it in the machine, put it under load, is to do one of two things. We can typically run a continuity test, which allows us to take our multimeter and put our pin locations on the pins to make sure that we're reading both the inputs that we'd expect to. But the benefit of having a connected system is a USB trigger here that we can connect to an end-of-line machine and have that run our electrical test for us. So whether it's a high pot tester, which we're manually probing, a multimeter, or in this case is a USB test that's running a electrical signal for us. When I power on, I can make sure that yes, this is set, my connector is set on my wires correctly, and I'm getting a good response from this mechanism. So when I trigger my continuity test on my work instructions here, I have a verification that everything's wired correctly, everything's functioning, and I can continue down the production line without risk of scrapping. As we've seen, integrating shop floor tools into worker guidance is the key to error-proofing and eliminating human errors. The great news is that Pico has integrated over 200 devices into our library, ranging from torque tools, electrical testers, and other equipment that can all be dragged and dropped into your product workflow. Tune into our next episode to see how easy it is to connect each one of those tools to one of your production stations.